Okay, so hey, train your plants every day. Jordan Scoble coming at you from the STEM lab. Let's see if I can pretty this up, put a little cosmetology on this map here, and do what you can do with it in the quantum physics lab. So there's been some cool ones. I just want to throw out some, general pro notes, and I mean general. We're not just talking about rock here. This is McDonald's. This is crew, man, and you want to be mayor, president, whatever. It's all the same stuff. Anyways, not many people can just jump in here. A lot of gravity if you ain't got the proper handler taking care of you when you first walk in these doors, or haven't learned or whatever. Anyways, running some good green, nice 1836s, nice pallets. Bang, look at that brick. Got to wash it off, take care of it. That's run the Italians up. So some things about, all things. When I play around with the IMA, I'm looking at it like IMA. That's a book, a model. But when you take it like a particle physicist, this table should actually be ground down every cut. Okay, this is one of those power notes. That ground down before every, we'll turn it, we'll make those two cuts, and then grind it down again, because you're never really sure, and it does stack up. It's very muddy in this water when you're looking at all the calculations. If you're like me, you watched How the Universe Works this morning before you come in, or whatever you're doing on national whatever. And, you can kind of play with a lot of those calculations like this. This has a lot to do with, one's real pretty. I can pretty this up for a lot of things. There's nothing wrong with it. There is some beautiful things about a mud puddle like that right here. That's the game of the particle. You're looking for degrees after certain things stacking. Those are kind of like your high spikes, why you're running the G-suit, feeling pressures on equations about why this map layout, and you're looking for, all right, I got my X-ray gun, right? Here it is. I'm on the floor. I got some things going on. When I think about time and this being an X-ray gun and the chemistry of it, I can see some linear stuff running pretty straight. Those are the master Feynman model sheets that we're going to use to help us generalize some base mechanics. It's good. Nothing else is messed up in here. That would change because of gravity and quantum mechanics what that looks like. Spikes would be all over the damn road. I mean, there's everything. That's string theory, super string theory. Remember, these are all A mechanics. You got to look for, when you're unifying it, that's general, not a Mason conversation. So there's that palette. It's good. You'd see that. When I look at that spike, it's just one clean pyramid in A mechanics. Obviously, even like this being a fairly clean setup today, I had to work it out. And you look back a little bit, you see on the Richter scale there's some crazy stuff. But anyways, you take some of those spikes and you say, all right, this one thing is on units based on how that particle, photon, works, not knowing its motion and position exactly. I can see it when I calculate it. It's moving 4 units in a second. Yes, it's there. And it's moving consistently on that, so a frame dimensionally is one move, the whole palette. And you look at that topo map and you see pressure on this mountain survival anagram that, surveyor utilize. Those are your lines. What's the main pressure points? It's inverted, not inverted. They call it not reverse symmetry. This one is, it's like square law, or not square law, inverse square law. You're kind of looking at those to make it a spike now. Now we're taking those dips and we're raising them up. We're looking for them on timelines, lining them up on other dimensional principles. Think about what you need to know about shooting a particle to do a certain thing, to generate energy off of it. Don't tell me I don't generate all kinds of energy off of this. Free radiance abound. You need to pick and choose. My point is, even directly using direct physics, there's some pretty things. There's value. There's a lot of frames that branch off of this if you're going to apply it, because it's a scene change flip thing in special relativity. That's how they play mathematics. When you're talking to your boss, you're talking to the customer, you're explaining it in special relativity. All right, You're looking at the floor in special relativity. General relativity says that's fucking physics. That motherfucker right there is going to bend light around it. It's that strong. You wouldn't notice it. This fork truck doesn't, you know. Get close enough to it, its fields change. Right on by. At least they should. What else? Why else? X, Y else? Z, function this shit out. 5 minutes. Look where we are in the day. Hey, boss man. Those are steps. Each general relativity step, each, if I close this off into a topo map, if I frame it with the X-ray gun, if I have it based in master plays designed down that are one off from what I'm determining to be this general relativity space and time, so then other numbers can be broken off of that, because that number doesn't really exist. It's in flux, it's in moving, it's not a thing until I say it's a thing. And that goes up, you know, hey, it's not a thing until it's a thing, you know, so just putting that out there. Oh, hey, that's your cheeseburger, that's your stick. Cheeseburgers will eventually get you, but if you want to try to eat that rock right there, that hurts. Dinner, get it right. See, we can tell. We can tell that, by the way. Look, when you come in here, kind of do one of these. Yeah, seasoned just right. So that's my note for the day. Pretty cool. You got any questions, comments? How is it useful for whatever kind of principle you want to base it? You want to help, you know, do put something to it as much as ask for something on the back end of that. You know, it's all A code to me. I could make that work and not screw up any of my models. You just give me timelines, what you're looking for, what are the main points. Here are not just a model, here are several of that same thing, doing different things in hypotheticals with timelines, space and quotes, and you know, just they're all one move. Don't think that they're so much more complicated than knowing all that. But if you've never sequenced a bunch of them in a row before, or don't know that you can do that with them, well, you're gonna have trouble. Why didn't it work this time? Plan it out. Well, this is that next step. It's a marshmallow experiment. It's command and conduct. It's Aristotle and common sense physics, and just chain of command. You know, that's, if I hadn't said it already, it's just civilization says this works this way. Poof. Every calculation by general relativity terms is going to set that. This is basically a photon from a galaxy far, far away. In comparison, quantum mechanics says those answers are real. General relativity says those are real. How do you compensate for it? Cheat that shit. Yeah. Poof, this is what that is. Your quantum mechanics doesn't really do shit all for... Right. Anyways, note of the day. Catch you in the next one. Get on that stick, you know, see what happens.